Okay, so now that we've covered the really, really, really simple part of Java, and it didn't take us very long, let's start talking about more interesting things. And we'll also start looking at some more interesting examples along the way as well. So we're going to talk about Java support for inheritance. How many of you guys remember covering inheritance in an earlier class? Okay, so it was probably covered. How many of you guys remember covering polymorphism in an earlier class? How many of you wrote programs that used polymorphism? Okay, so this stuff will hopefully be a review. I'll go through it quickly. If you didn't cover it or you forgot it, let me know and I'll slow down. These are some of the more interesting features of Java as an object-oriented language. So we're going to talk about what inheritance is and how it's supported in Java. And there's a reason why I show this picture, and we'll come back to it in a second. Okay, so object-oriented languages, of which Java is one example, but C++ and Smalltalk and Simula 67 and C# and Python, they all have these features. They all allow inheritance as a vehicle to reuse existing code. Existing classes can be reused by inheritance. And as the name implies, and is shown on this picture, inheritance basically means that the class that inherits from something else, which is called a subclass, inherits code and data from a superclass. And so it has those characteristics plus perhaps some other things as well. So that's kind of the, the metaphor here of the inheritance of the bugs. In Java, you indicate something uses inheritance by using the extends keyword. Now, there's also this implements keyword, which is used for interfaces. And in some sense, interfaces that are implemented by classes are also a form of inheritance. But we won't cover that right at this moment. Let's focus on extends. So here we have, for example, abstract set. And as you can see, abstract set has some things. And then we extend it to make a simple set. And we'll talk about this in a second. So basically what inheritance is going to allow us to do is it allows the subclass to inherit the non-private fields and methods from a superclass. Now, they also inherit the private fields, but you can't get to them. They're in a lockbox somewhere. So for example, here, simple set inherits max array size and hash code from abstract set. So simple set is the class that we wrote, and abstract set is something that comes out of the Java collection framework. And so when we have this relationship, these things come along for the ride into simple set. Now, if we make ourselves an instance of simple set, we say new simple set. And notice, by the way, I say new simple set, but I can treat this as a set. That's one of the fundamental properties of object-oriented programming, that a subclass can be used in the context of its superclass. And now I go ahead and I make a call to s.hashcode. And so the question is, which method is called? Well, in this case, there's only one hash code, the one that's defined up here in abstract set. So that's the one that's actually going to be implemented. Or, sorry, actually going to be called. And I think actually hash code probably comes from the class object, which is the parent of all classes. But it's also, of course, part of abstract set as well. When I call add, however, add is not defined here in abstract set, or maybe a better way to put it is it's defined in abstract set, but it's implemented here in simple set. That's because it's a so-called abstract method up here. We'll talk about abstract methods later. So when I say s.add, that's actually going to call the method that's defined down here in simple set. Now later, we're going to come along when we talk about polymorphism, and we're going to say what would happen if, for some odd reason, simple set was to define a method called hash code with exactly the same signature as abstract set. If that were the case, if the subclass overrode the method from the superclass, then when we said s.hashcode here, that would call this method, not that one. But that only happens if we override this. And we'll talk about that later. For the sake of this discussion about inheritance, let's not focus much on overriding. We'll get to that towards the end. Now, a great place to see this stuff used in all of its full-blown glory is, of course, the Java collections framework. And that's what demonstrates all these things. There's lots and lots and lots. There's dozens of classes and interfaces that are organized hierarchically there, which you can learn about. And you'll get a chance to play around with a lot of this stuff in this class. And as you can see here, we have all these hierarchies, right? So we've got like this collection and these lists and various kinds of lists, and then we have maps, and we've got different kinds of maps, and they're all related to each other by inheritance one way or another. So here's a simple example. This is the list hierarchy. As you can see, we have list, which is an interface, and then we have abstract collection. An abstract collection, you can see abstract list implements portions of list, and then abstract collection extends the abstract list. And then we've got vector, which extends abstract list, and array list, which extends abstract list. And then these implement various kinds of abstract data types, ADTs, that do different implementations for these things. So vector works differently from abstract list. But the key point here is that we're going to systematically reuse data fields and methods. So it all kind of hangs together in a way that, ideally, if done right, will enforce the principle of least surprise. Right? If you know what a list is and you know what that interface looks like, then an array list or a vector has that interface, but the implementation may behave in slightly different ways and does behave in slightly different ways. Now in Java, there's something called the class object, which is kind of a funny name. And that's the superclass of everybody. It's like the godfather of the classes. And all Java classes inherit from object. Even if they don't directly inherit, they implicitly inherit from it. So here's some of the methods in object. There's a lot of methods in object, but here are some interesting ones. We'll look at some of these things. And these can be used by all non-primitive types. What's a primitive type in Java? Int. Int with lowercase I, right? Long with lowercase l, double with lowercase d. These are called primitive types or built-in types. And they're a little bit quirky and a little bit different from the other types. And there's a lot of historical reasons why they're there that we don't have to go into, but they aren't quite the same as the others. So anything that's not a primitive type will have these methods. So for example, hash code is used to make a hash for an object. Equals is used to check to see whether two objects are equal to each other. And then there's a bunch of methods that are used for synchronization and methods that are used for scheduling and coordination and so on. We'll perhaps talk about these later because they're part of the concurrent part of Java. Even if a class does not explicitly extend object, it still gets those methods, right? So here's a class that's called process, and the process class will implicitly inherit from Java lang object. So any of the methods that Java lang object defines, you get through process. And so this is kind of what it would look like if you were to draw a UML diagram. This, by the way, is a UML diagram or a snippet of a UML structure diagram. We have the name of the class, its methods, and then we have this little arrow which says process inherits from object. That's just kind of showing the structure. And all objects implement the methods, including arrays and stuff like that. So this is the most general of all classes. It serves as the root of a hierarchy of classes that you can use for various kinds of things. Classes towards the bottom of the hierarchy are, quote, more specialized, and classes towards the top of the hierarchy are more generalized. And sometimes we talk about customization or specialization, because as we go further down the hierarchy, we're adding more details. We're adding implementation details. We're really defining methods with algorithms and so on that do something useful. So here's a very simple example, again, just kind of filling in the blanks. So we have object, abstract collection, abstract list, vector, array list, linked list, bloppity, bloppity, blop. Those are things that are done for you by the designers of Java. There's a couple of interesting quirks to remember about Java. This is confusing, especially if you come from C++. In Java, the equal operator is used to check to see if two objects occupy the same address space in memory. Not that their contents are the same, which is different, oddly enough. If you want to know whether the contents are the same, then you have to call the equals method. So let me see if I can give you an analogy that might help to make this distinction a little bit more clear, right? So back in the day, actually even today, people sometimes have maybe multiple phones with multiple phone numbers. Today you might have Google Voice. You may actually have multiple phone numbers, but they're the same phone, right? A little confusing. So back in the day, if somebody gave you a phone number, then, assuming they gave you their phone number, that was a way to get to them. And you knew that because you just look at that number. So if you got a phone number from one place, like you looked it up, you Google searched it, or you looked it up on Vanderbilt People Finder, and you found the same phone number somewhere else, you could be assured that that was referring to the same phone, right? Because you had two numbers that were the same. And that's kind of like the equal operator. However, if somebody had two phone numbers, you wouldn't really know if it was that same person unless you called them, right? So kind of called them on both numbers. And if the same person answers on both numbers, that's the same person with two different numbers. Even though they have different addresses, it's referring to the same thing, or this equality. So that's a little bit more like equals, right? Equals actually has to do a little bit more checking to see whether something is the same rather than just comparing their addresses. So equals used to check the values in a collection or a string or whatever to see if they have the same value, which is not quite the same as being the same object. It's a more expensive operation, but it may be more useful in lots of cases. So that's the difference between equal, the operator, and equals, the method defined in class object. Now, when we start talking about subclassing, there are three purposes of methods in subclasses. So there are three reasons why we do that. And to make this more concrete, we'll look at the stack class from the Java collections framework. So as we'll see, class stack extends vector. And as you probably remember, hopefully from 201 or before, a stack is a LIFO, or last in, first out data structure that enables applications to push and pop items to and from the stack. So hopefully that's not a surprise. So it extends vector. This is actually a weird design, but that's what they do in Java, so I'm using it as my example here. So basically, one reason that you use inheritance is to augment the subclass API. So what does that mean? So that means that stack, this guy, inherits fields and methods from the vector superclass. So here's a simple example. Vector defines isEmpty, and we can reuse the isEmpty method from vector when we use a stack. So stack uses isEmpty, which it inherits from vector, and it percolates through the stack's public API. So isEmpty is inherited from vector, and it can be invoked on a stack instance. And this is what's often called implementation inheritance. We'll talk about that a little bit more in a second. Another thing you can do is you can use the inherited method to implement the subclass method. So here's an example. So we have push, right? So push is a stack method. You don't see push in a vector. So push is a stack method. But when push is implemented, it uses the vector's add element method in order to do its thing. Now, the reason this is somewhat of a wacky implementation, and don't blame me, blame Josh Block or whoever wrote this for the Java collection framework, that also means that add element is going to be accessible to people who use a stack, which is kind of bizarre. So that's the downside of implementation inheritance. But that's another reason to use it, to implement something that you get from the superclass. So reason number one, expose the interface to the public interface of the subclass clients. Reason two, use it to implement a subclass method. And then reason three, which by the way is the main reason to do inheritance, but we're going to suppress that for the moment till we get to polymorphism, is to be able to do overriding. So that's to be able to have the subclass have the same method name, but redefine or define, depending whether it was an abstract method or not in the superclass, redefine or define the method to do something. And that's the primary reason we do it. So here's a simple example. We have a hash map, which is another Java collection framework method. We have abstract map. Abstract map defines entry set, which is an abstract method. And then stack will actually implement entry set. I'm sorry, stack. Hash map will actually implement entry set to do something because it's a hash map versus a tree map or some other kind of map. And so that's the main reason we do it, to be able to customize and specialize. And we'll talk a lot more about that. So that's called overriding. If you take a method that exists in the superclass and it's a non-final, non-static method, then we can override it and redefine it in the subclass. And that's the real beauty of this thing. And we'll talk about that in a second when we talk about polymorphism. All right, so that's just a quick synopsis of Java's support for inheritance. Shouldn't be anything too mystical there, hopefully.